Hi, this is Victor and welcome back to my math tutoring channel. In this video, we will find the radius of convergence and the interval of convergence of the series sum n equals 0 to infinity of n times x plus 2 to the power of n divided by 3 to the power n plus 1. And the technique that I will be using here to prove it is the ratio test. And we know the ratio test is we take the series, we take, let's say, an is equal n times x plus 2 to the power of n divided by 3 to the power n plus 1. And then we find an plus 1 by replacing n by n plus 1. So it becomes n plus 1 times x plus 2 n plus 1. So every n I replace it by n plus 1 divided by 3n plus 1 plus 1. This is my an plus 1, and the ratio test is the absolute value of an plus 1 divided by an. That's the ratio test is equal to this. And then I will study the limit of the ratio test. If the limit of the ratio test is less than 1, we say that the series converge. If the limit when n goes to infinity here of the ratio test greater than 1, it diverge. And if it is equal to 1, it is inconclusive. If it is equal to 1, it is inconclusive. That means I have to find another way to prove if it converge or diverge. So let's start by doing the ratio test, which is an plus 1 divided by an. So I have to study the limit when n goes to infinity of the absolute value of an plus 1, which is here, my an plus 1. That's my an plus 1, and that's my an. Time x plus 2 to the power of n plus 1 divided by 3n plus 2, 1 plus 1 equal 2. And instead of saying divided by an, I will multiply it by an, but I will flip it. So my denominator become the numerator. My denominator used to be 3 to the power n plus 1, so it become my numerator. And my numerator would go to the denominator here, which is n times x plus 2 to the power of n. So let me rewrite that limit in a way that I can simplify it easier. So I see here I have x plus 2 to the power n, and here x plus 2 to the power n plus 1, and here I have 3 to the power n plus 1, and I have 3 to the power n plus 2. Let's try to play with it. So my limit become, when n goes to infinity, of absolute value n plus 1 time x plus 2 multiplied by x plus 2 to the power n, because this would be to the power 1, and then this is x plus 2 to the power n plus 1 divided by 3 to the power n plus 1 multiplied by 3 to the power of 1. So it becomes 3 to the power n plus 2, this, time 3 to the power n plus 1 divided by n x plus 2 to the power of n. And here I can see that I have x plus 2 to the power of n here and x plus 2 to the power of n. I can simplify by it. I have 3n plus 1 and I have 3n plus 1 here. I can simplify. So my limit become, when n goes to infinity, and here I know n is between 0, my n here is between 0 and plus infinity. So my n, I know my n is always positive. It's the x that I'm not sure if it is positive or negative. So I will keep the absolute value around the x's. Anything that does not have x, I will put it outside my absolute value. It becomes n plus 1 divided by n, absolute value, x plus 2 I can put the divided by 3. I know 3 is positive, but let's do it that way. So this will become equal limit when n goes to infinity of n divided by n is 1 plus 1 over n times x plus 2 divided by 3. So when n goes to infinity, that would go to 0. 1 divided by infinity is equal to 0. So I will have 1 multiplied by the absolute value of x plus 2 divided by 3. So which is equal x plus 2 divided by 3. So it becomes x plus 2 divided by 3 as absolute value. So if it converges, I know it should be less than 1. And if it diverges, it should be greater than 1. X plus 2 divided by 3 should be greater than 1. So from this, I can find that x plus 2 absolute value is less than 3. I did cross multiplication. And from here, I can find that x plus 2 absolute value greater than 3. So it converges here. And it will diverge here. So the radius of conversion, that means my radius of conversion convergence is equal to 3. And now I want to study the interval of convergence. Interval of convergence. So I will ignore the divergence. I want to study the interval of convergence, so which is the absolute value to x plus 2 less than 3. If I want to take out the absolute value, so I have to take it one equal to plus 3 and the other time equal to minus 3. So I would have x plus 2 less than 3 or x plus 2 less than minus 3. So from here, I would have x is less than 3 minus 2 is 1, or x less than minus 5. So my x is between minus 5 and 1, is between minus 5 and 1, and my interval of convergence is minus 5 and 1. If you like my video, please subscribe to my channel. That would help me tremendously and it would encourage me to do more video like this. And if you push the like button, I would really appreciate it. Thank you for listening.